Going to continue on talking about trigonometry. Today we're going to talk about equivalent trig functions as well as some reciprocal trig functions. So starting off on page 2 of the notes, we see here the idea of what value from 0 to 360 is equivalent to cosine of 92 degrees. Okay, well, our cosine of 92 is a quadrant 2 value, and its reference angle, how far it is from the x-axis. Well, the closest x-axis value is 180 degrees. So if we did 180 minus 92, we would get our reference angle to be this time 88 degrees. That's our quadrant 1 angle. And we can use 88 to find the other equivalent angle measures in what I like to call kind of the family. So the quadrant 3 value that would have the same reference angle, we'd have to do 180 plus. So we'd have 268. And then we would do 360, since quadrant 4's closest value would be 360 minus that reference angle of 88. And so that'd be 272. Now, out of these equivalent, I like to call them again reference family members. If we're talking specifically about the cosine, we know cosine is positive in 1 and 4, negative in quadrants 2 and 3, because our x value is positive in quadrants 1 and 4, negative in 2 and 3. So when they're asking us specifically about 92 degrees, the other place it's going to have a negative cosine value as well is when it equals 268 degrees. And what we could do is we can kind of even check this fact. We're in degrees mode. If I take cosine of 92 degrees, I see that cosine of 268 is also going to have that same exact cosine measure of about negative 0.034. Now, the next part then is asking us, again, a similar idea. This time we are dealing with a reference angle a given angle of 9 pi over 5. Now, if 9 pi over 5 is throwing you off to know what it is in degrees, of course, we can convert it to degrees by multiplying by 180, and that's the same thing as saying 324 degrees. So 9 pi over 5, or 324 degrees, is in quadrant 4, and its reference angle, think about how far is this from 2 pi? Well, if we take 2 pi minus 9 pi over 5, just don't type the pi's in the calculator, math, enter to turn that into a fraction, we see that we are 1 pi over 5 away from that closest x-axis. That's going to be our reference angle this time. And then to find the quadrant 2 and quadrant 3 values, you would take 1 minus your reference angle, so 1 pi minus pi over 5. Again, just don't type the pi in the calculator. We get 4 pi over 5. And then quadrant 3, you would do 1 plus your angle measure. Okay, again, just don't type the pi's in your calculator. Math, enter. We see that it would be 6 pi over 5. So again, here's all of the angles that are going to have the exact same x, y values, just some positive, some negative. In this case, when we talk about sine in quadrant 4, our sine value is negative there. Okay, it's positive in quadrants 1 and 2 because the y value is positive. It's negative in 3 and 4 because our y value is negative there. So we would talk about the other place besides 9 pi over 5 where our sine is negative is going to be at 6 pi over 5. All right, next one we have another tangent value, and again, if you're not 100% sure where 29 pi over 31 is, you can always convert this to degrees and see, okay, what quadrant are we in? In this case, 168 is in quadrant 2. And that makes a little bit of sense because we aren't quite at 1 full pi. 1 full pi, if your denominator is 31, would be 31 pi over 31. So we're just short of that. And again, if you think about how far am I from my closest x-axis value of 1 pi, if I subtract away 1 pi minus 29 pi over 31, we are 2 pi over 31 away from that. That, again, is my reference angle. And then if I did pi plus that reference angle, it would give me quadrant 3. If I did 2 pi minus that reference angle, it would give me quadrant 4. So I can get those other two family members, again, because we have pi plus the theta value. Again, our theta is the quadrant 1 value, pi plus theta here, and then 2 pi minus theta will give us quadrant 4, that's 60 pi over 31. Again, we get that theta from doing 2 pi minus the theta. Now this time we are looking for where is our tangent value equivalent. Well, tangent is positive in quadrants 1 and 3, negative in 2 and 4. So when they're asking us, okay, which one is equivalent to 29 pi over 31, we would take 60 pi over 31. That would be the equivalent. And again, this time we're dealing with radians, but we could test these facts, right? If I take the tangent of 29 pi divided by 31, I would get about negative 2.05, and then the same thing should happen when I take the tangent of 60 pi over 31. These should match. We get that same value. All right, now this leads us into our idea of some reciprocal functions and where things are positive and where things are negative. So sine, cosine, tangent. We've been dealing a lot with these over the past few lessons. And a reminder, we also identify sine kind of with our y value, cosine with our x value, tangent with our y divided by x value. Well, each of these three original functions have what we call a reciprocal function. So in this case, sine's buddy is cosecant, that is hypotenuse over opposite, or you could think about, you would flip your y value. Secant is your hypotenuse over your adjacent, or again, you're flipping your x value. Cotangent, adjacent over opposite, or think about x value over y value, the flip of the tan. So part of this then, looking at these values, is looking at our unit circle values. For instance, we have the cosecant of 45 degrees. That is really going to relate back to our buddy's sine of 45 degrees. So think about the sine value at 45 degrees is square root of 2 over 2. And what we're going to do is we are going to flip that to get the value of our cosecant. Now we know we must rationalize if we end up with a square root in the denominator. In this case, what's going to happen each time that you rationalize 2 over square root 2, it'll just simplify to be square root 2. Now the secant of pi over 3 is really dealing with the cosine of pi over 3. And if we look at that x value at pi over 3, we see that it is 1/2. So we will take that cosine value of 1/2, flip it now, instead of being 1 over 2, it's 2 over 1. So 2 would be our secant value. Now cotangent we talked about is your x value divided by your y value. So at 45 degrees, we're at square root of 2 over 2, comma square root of 2 over 2. So if we take those x and y values and divide them, whenever you divide something by itself, it just becomes 1. Cotangent again at pi over 3, again we want to focus on that coordinate. We are going to take that x coordinate divided by the y coordinate, so 1/2 divided by square root of 3 over 2. Similar to with the tangents, we notice that the 2's cancel, and when we rationalize, this one becomes square root of 3 over 3. Now occasionally what's going to happen, if we look at the cosecant here of 0, is we would look at the cosecant's buddy sine at 0 degrees, and the sine at 0 degrees is 0. So when we flip that, okay, we would now have, instead of 0 divided by 1, we have 1 divided by 0. That division by 0 would cause us to have a cosecant that's undefined. That also would happen with something like secant of pi over 2. At pi over 2, if we think about secant's buddy cosine, our cosine value is 0. our x-coordinate. So again, when we try to flip that, we end up getting undefined. Now on the flip side, if we look at secant of 0, cosine at 0 is 1. So if we flip 1 over 1, we would just get 1, or cosecant of 3 pi over 2, aka the sine at 3 pi over 2. The sine value is negative 1, so if we flipped that, we'd have negative 1 over 1, so negative 1 there. All right, now another one here to look at, secant of 7 pi over 6. Okay, that again is going to relate back to its buddy cosine. And if we think about the cosine of 7 pi over 6, that x value there is square root of 3 over 2, but it's in the third quadrant, so it is negative. Now, if we flip that, similar to what we did up above with square root of 2 over 2, we must rationalize this because of that denominator being a square root. So we end up with negative 2 square root 3 all over 3 as our simplified version of that. All right. Thanks everyone for watching. We'll work more with these in class.